Hi dear students. This video records subjects a solid model creation using the tools of AutoCAD as an example. Okay then, first using the orthographic views shown on the sheet inform you on the geometry of the object. Okay. Yes. Here is the pictorial figure of the object and the front and the top views, orthographic views. Well, okay, then let's start. Well, you know, if in the system as hardware, there is only one, say, monitor display. Well, it may be recommended. Well, have the worksheet, say that this is the worksheet for this study. Have the worksheet in AutoCAD environment. At present, this sheet is in HTML format, PDF format. Well, I see the sheet in say HTML environment. Since AutoCAD does not accept PDF and HTML files into their environment, I'm going to change the format of this sheet from say PDF to picture. For that purpose, I'm gonna take this screenshot, clicking on the key of the keyboard, print screen, and then using Paint, well, as the software to convert the format from PDF to picture. Yes, paste the screenshot, and then okay, select this part of the screenshot. Well, I have the orthographic views and the pictorial figure of the object, and crop the rest. Okay, and then select this screenshot. First save the file in the memory, save as. In my computer, I know the address. Yes, this folder. Well, to make it distinguishable, I'm going to name the file. Well, writing the name with my surname first, and then staff number, and then just say that class work. Well, I'm recording this video today. It is the 2nd of April. So, April 2. Well, the format is, JPEG. Drop this list, and I selected this format. Okay. And then, in AutoCAD, for having a new file, you know, this is the way to follow. Click on the new file creation button, and in this dialog box from light background folder, select the template option. Well, since the given dimensions are in millimeter on the technical drawing sheet, and also, well, this example obey to the rules of the International Standardization Association, I'm going to select this template option, ISO template. If this template is selected, you know, AutoCAD knows that the first quadrant is selected and the unit of measurement is millimeter. Okay. And then, well, to be able to make the zoom extent facility functional, well, write this command, zoom. Okay, and then click on down direction key of the keyboard and select all option. Okay, and then at present there are, you know, two layers in the structure of this file, 0 and AM0. I'm going to create well a user layer in which in that gonna have the solid model of the object, and activate a system layer, you know, to be able to mark points, critical points, endpoints, intersection points. Say that at the construction stage there are some points to mark. I use transfer lines. For transfer line creation facility, there is a system layer. To be able to activate that layer, the thing to do is that, you know, well, use the facility for the first time in the file, and then the layer going to be activated. Okay, since the transfer line tool of the software is available in 2D mode, well, at present from the ribbon it can be seen I have the 3D tools along the ribbon, so mode is 3D mode. I'm going to switch the mode from 3D to 2D. Clicked on this listing arrow and selecting mechanical option. Yes, can change the mode from 3D to 2-dimensional. Okay, and then, well, to be able to activate the system layer, it is used by the software well, as the layer of transfer lines. Drop this list and then, well, create a transfer line, which one you like. It is not to have a transfer line at that stage, but just to activate the layer. I selected horizontal option and then arbitrarily created a horizontal transfer line. Press escape button and then delete this transfer line. Well, I'm sure I have a layer to its name in this list. It is AMCL. It's a default name for this layer, transfer line layer. I'm going to change the name of that layer. Instead of well, having codes as the names of the layers, it's a good practice. Well, name the layers with meaningful words or phrases regarding the content of the layer. Okay, for changing the configuration of existing layers, for creating user layers, you know, this is the button to click in layers panel at the top corner. Find mechanical layer manager button, and with a click can invoke it to the screen. And then, well, AMCL is the default name of the transfer line layer, so I'm going to rename it. Right click, rename, say transfer lines. For transfer lines, well, I'm going to use select this color, dark gray. Line type is correct. Line thickness, well, recommended line thickness. Transfer line is a thin line. 0.2 is a suitable thickness value. Clicked on this new layer creation facility tool, and then create a user layer. It is to have the solid model of the object. So I'm going to name this layer saying object. Okay. Well, as the line color for this layer, well, select dark blue. Okay. Line type correct. Line thickness 0.5 is recommended millimeters. Clicked on apply. Clicked on OK. Well, one more layer. In the layer, I'm going to have the worksheet at the construction stage, model construction stage, creation stage. I'm going to use that picture. So bring the managing dialog box and clicked on new layer creation button and say construction is the name of the layer. For construction layers, as the line color, use red. It is my convention. Line thickness 0.2. Clicked on apply and OK. And then in the memory of the computer, I know it is this folder and that subfolder and this nested one. Well, I am sure the worksheet is in this folder. Here it is. Bring the cursor onto this picture file, right click and then say copy. And then in AutoCAD mechanical environment, paste this picture in construction layer. Select construction layer from the bundle and then clicked on paste button. Well, this rectangle, is the frame of the screenshot, frame of the picture. Anchor it at a certain place and with a click, and then twice clicked on enter key. Here is the worksheet. And then OK, start. Well, first I'm going to mark the center point of this cylindrical part, and relative to this center point I'm going to mark this corner points. Okay, relative to the center, the coordinate of the corner, this corner, is 50 millimeters in the horizontal direction, 125 millimeters in the vertical direction. These are the coordinates for this corner point relative to this center. Okay, well, I'm going to mark the center of the say the circles using this tool. Well, since it is for this tool there is a system layer, it is the transfer line layer, no need to select that layer, dropping this list, because whatever the active layer is, well, the transfer lines will be created where in that layer, transfer line layer, by the software. So it is automatic. If for the facility, it is the facility to output something is the one, it has a system layer, then yes. well, the outputs of the facility are always created in the content of the corresponding layer. That layer is automatically selected by the software. Okay, well, arbitrarily mark the point with a click, and this point is the intersection located by the intersecting transfer lines, and in my consideration it is this center point. Okay, and then press escape button. Well, the other transfer lines, one of them passes through this corner, the other passes through the other corner, cannot be marked arbitrarily, of course. Well, relative to this first located point, well, locate the others using the given location dimensions. Okay. Yes. Well, I'm going to have an annotator to be able to make the things more understandable. Yes. Well, here I mean, well, this point, this intersection in my consideration corresponds to here, and relative to point A, this point, well, the location dimensions of point B, well, in the vertical direction 125, and distance from here to there, corner to corner, from the top view I see that it is 100 millimeters. So relative to point A, the other location dimension for point B is 50. This distance is equal to 50. To be able to locate point B with respect to point A, well, I'm going to use the transfer line facility, although here it is written construction, but say the correct word to notify the user on the function of this facility is transfer lines. Okay. To be able to mark the points with respect to the already created transfer lines, well, this is the option to select, parallel with full distance. And then relative to the transfer line, it passes through the center of the circles. Yes, the location dimension for the transfer line, it passes through point B. Yeah, the distance is 125. Here is the reference indicated with a click, and then into the box of the train, write the location dimension 125. Press enter, and then since the point to mark via using the parallel transfer line is at a lower level with respect to the reference, move the cursor in the down direction and then make a click. Yes, this transfer line is the one, it passes through this corner point. Okay, where is the corner? Corner point is 50 millimeters away. Indicate this vertical transfer line as the reference. Write 50 into the box. Press enter. Since point B is at the right hand side of point B, move the cursor to the right and then make a click. Well, this parallel transfer line and that parallel transfer line intersect each other over here. It is point B. Well, relatively to be able to, to be able to mark this corner point, well, I'm going to use this vertical transfer line as the reference. Location dimension is 50, but the point to mark is at the left hand side, or the transfer line, it passes through the center of the circle. So move the cursor to the left and then make a click. Yes. Well, the points while using transfer lines which I marked, well, this is the reference point. Say that point A, it corresponds to this point, center point, and point B, point C. This intersection is B and this intersection is C. I know this. Okay, my purpose, well, at this stage is this. I'm going to have such a figure. Well, at this stage. And then, yes, show this part. Sorry, well, not this. I'm not going to draw this circle. Have this region. Yes, this region. And then apply the extrusion process after having the model of the main part of the object, and then add the other features step by step. This is my plan. Okay. And then, yes, at this stage, after marking the points A, B, and C, okay, then select the objects layer from this list with a clicked on object option, and then create the circle. Well, I know the diameter of the circle, it is 40 millimeters. Well, this is the center point, I know. Yes, indicate this point as the center, and then write the diameter into the box. It is 40. Okay. And then, well, from this projection, I see that, well, and also from this photograph, pictorial figure, I see that the inclined surface, this inclined surface, which one? This inclined surface is tangent to this cylindrical surface. Well, here, yes. This line is the edge of that inclined surface. It is tangent to this cylindrical surface. So on the projection, it is tangent to this circle. Well, the figure right now, trying to draw it, is the sketch to have the regions to indicate at the model creation stage. Well, I know at this stage, well, there is a tangent line. It is tangent to the circle over there, and it ends at this intersection point. Well, select single line creation option. Clicked on this, and then, well, you know, to be able to create a line, as tangent to a circle or circle arc, it is the trick. First, start the line creation process, and then change the snap configuration of the software. Bring the cursor to the vicinity of this listing arrow, and well, disable all the other points from snapping, either deselecting the already enabled ones with successive clicks one by one, and then only select tangent option, okay, to enable, or, well, clicked on the last option in this list, bring this setting dialog box, clicked on clear all button. It is for disabling the characteristic points from snapping the cursor. Only to enable tangent points, make a click into this selection box, which one you like. And then after enabling the tangent points only, bring the cursor to the vicinity of the circle at this side. While seeing the green tangency symbol, it is highlighted by the software. Make a click and then, well, I'm going to indicate this intersection as the terminal point of this inclined line. But since at present for intersections there is no enabling to snap, drop this list and now enable the intersections, selecting intersection option for snapping. And then, yes, while this intersection can snap the cursor, this intersection can be indicated. While seeing the green cross, it is the symbol that is used by AutoCAD for making such a highlighting. Make a click. Okay. And then, well, do the same thing. Press escape button at the other side. Start the line creation process. Rechange the snap configuration. You see, well, software reset itself and enabled itself for some for snapping for some characteristic points. Okay, enable the tangent points only for snapping. Okay, and then, well, indicate the circle while seeing the tangency symbol, and then, well, enable intersection points for snapping, and then indicate this point. Okay, and then, well, after having these two tangent lines, then, well, I'm going to join this point to that point, creating a line. Well, have such a figure at this stage. Well, for being safe to site, I'm going to save this file because I use a certain time. Well, so this drawing, this studying gain a certain value. It is well valuable to save. Okay, save as. Show the address. I know, well, in my computer this is the address. Okay, say that, surname, ID, classwork. Okay, today I'm recording the file, the things, today it is the 2nd of April. And then, well, I see I have this parallel line to this boundary, this parallel line, this parallel line. At this sketching stage, I'm going to, well, omit this roundings, omit this rounds, fillets. To be able to create a parallel line, well, it is recommended to use offset copy technique. Well, I use this transfer lines for marking the points, center point and the corner points. Well, no need to keep this transfer lines in the screen. I'm going to turn the lights of transfer line layer off. You know how. Well, make a click on this lamp symbol and transfer lines will disappear from the screen. Okay, and then start the offset copy process, clicking on this button. Okay, specify offset distance, first wagon of the train. AutoCAD, well, reminding me, saying that specify offset distance on the thing to do at that stage. Well, the offset distance, the shortest distance between parallel lines is 15. Okay, then so into the box write 15, press enter, and then, well, indicate this line and then move the cursor in the down toward the inside and then make a click. Indicate this one, move the cursor inwardly, make a click. Indicate this line and move the cursor and make a click. Okay then. After creating the parallel copies, press escape button, stop the running, and then trim the further extensions. Well, trim this part, trim this part, trim this part, this and that. Okay. Well, I'm going to trim this part for having a region. Okay, I'm going to create the hole. You see from the pictorial figure there is a hole here, and also on the base, at the base, there are two more holes, smaller in size. I'm going to create the holes later. I'm going to create these fillets later. Okay then, well, save the file one more time, and then well, convert this figure to a region. Well, since I created the segments well, using single line and circle creation tools at present, although it's a closed boundary, but since the lines are not in continuation, not the terminal points of the lines well, coinciding to each other respectively, it is necessary to convert the figure to a region. Expand the drawing panel and select this button. It is the facility to convert the drawing to a region if possible. Start the process, and then using windowing method, I select it all, press enter, and then yes, two regions, this region and that region. Okay, and then yes, to be able to apply the model creation process, well, by the way, here from the top view I see that the thickness of the main part, thickness of this part is 5 millimeters. Okay, change the mode from 2-dimensional to 3-dimensional. Select 3D modeling, and then to be able to see the direction of the extrusion process, well, you see I tilted the drawing, and then apply the extrusion process. Indicate this boundary, indicate this one, do it, indicate. Well, since there are two regions bounded by this and bounded by that, well, indicate both of them. At this stage, press enter, and then, well, the thickness of this part is 5. Write 5 and press enter. Okay. And then, well, to be able to see, well, the model at this stage, not in wireframe appearance, but more realistic, let me select conceptual option. Well, I see okay, I see. Well, this part is solid. Well, I'm going to subtract this part from the rest. Boolean algebra, indicate this one, press enter, and indicate this part, press enter. Yes, I subtracted it. And then save the file one more time. At this point, to be able to create the cylindrical extensions at both of the sides, well, from the top view I see the total depth of the cylindrical part is 15. The thickness of the main part, the existing part, is 5. 15 minus 5 divided by 2. This means, well, the depth of the cylinder is 5. Depth of the other is 5 millimeters. Okay. I know if dynamic UCS button is on, then indicating a surface, the origin of the coordinate system at the coordinate displacement process, origin is located to the center of the region. Okay, to be able to create a circle here, to extrude the cylindrical extensions, I think do it. Well, locate the XY plane as coincided with this surface. Okay, while this surface is being highlighted, snap enabling, endpoints, for endpoints, yes, enable the software such that endpoints can snap the cursor. Okay, while the surface is being highlighted, indicate this corner as the origin, indicate this corner as the other point along the x-axis, and indicate any point in the plane, for instance this point, to have the XY plane as coincided with the surface. And then, relative to this corner, create a circle, select center diameter option. Okay, since here for center points there's an enabling, when I bring the cursor to the vicinity of this circular boundary, I see AutoCAD highlighting the center of the arc. It is the center to create a circle. Or instead of using snapping, then relative to the origin, write the x and y values for the center point. Abscissa value is 50, ordinate value is 125. But here you see I use snap technique. The diameter of the circle is 40. And then after creating this circle, then apply the extrusion process. Indicate this circle, press enter. I couldn't indicate, so the rest of the model snapped my cursor, so I'm going to change the mode to wireframe. Much more easily can indicate the sketch. This circle is the boundary of the region. Indicate and then press enter. and then create a cylindrical extension. The thickness of the extension is 5. Okay. And then yes, well, check whether, yeah, that is okay. Of course, after creating this, then we'll unify it with the rest. Unification process. Indicate this part, indicate this newly created feature, and press enter. Now it is a feature. Do the same thing at the other side. I'm going to coincide XY plane with the surface, origin, abscissa axis, and indicate any other point, characteristic point over the surface to direct the y-axis. I'm sure XY plane is coinciding with the surface, so well, if I draw a circle, it's going to be in the plane over the surface. Start circle creation process. Similarly, I'm going to use snap technique, or if you want, I can create it say writing the coordinates of the center point, coordinates of the center point relative to this origin. Abscissa value is 50. Clicked on comma key. Ordinate value is 125. Press enter. Yes, you see, not snapping, but using writing the coordinates, I located the mark the center of the circle. Diameter is 40. Press enter, and then apply the extrusion process. Managed to indicate this circle. Press enter, and then in this direction the length of the cylinder is 5. Okay, similarly apply the unification process, indicate this part and indicate the newly created part. Press enter. Okay, then well, by the way, I'm going to orient the model well, like this, using orbit facility. Okay, I'm going to define this orientation as the home positioning for this model. You know how I broke the cursor onto cottage symbol, right click the mouse and bring the cursor onto this option. It says set current view, not view, had to be orientation as home. Select this one. Save the file one more time, and then yes, I'm going to create a circle over here, and then a cylinder, and subtracting the cylinder, I'm going to have this hole. Okay, diameter of the hole is 20. Okay, displacement process, well, indicate what the center point. For center points, well, enable the center points to snap. Well, I located the origin of the coordinate system at the center and indicate this midpoint. Well, for midpoints, enable midpoints, selecting midpoint option. Okay, to be able to fix the orientation of the x-axis, well, indicate this midpoint, indicate the other midpoint, adjacent endpoint midpoints. Well, made a wrong click probably. Do it again. Well, for endpoints, midpoints, center points, yes. Well, snap enabling is exist. Okay. Well, coincide the origin at the center, and then, well, okay. Well, press escape button. This is easier. Well, this is a surface, circular surface, and it is centroid is the center of the edge of the drill. So, since dynamic UCS button is on, well, just start the displacement process. No, not necessary. Just start the circle creation process. Okay, and then bring the cursor to the surface, and then, well, specify the center. How? By snapping. For center points there is an enabling, and then yes, I brought the cursor to the center. It is being highlighted. It is the center of the surface, and then it is also the center of the edge of the drill indicated, and then create a circle. The diameter of the circle is 20. Okay, after having this circle, then apply extrusion process. Well, indicate this circle. Yeah, well, okay, then change the visualization style to wireframe, and easily can indicate the circle. Press enter, and then create a cylinder in this direction. It is for drilling purpose, you know. And then subtract this cylinder from the main part. Indicate the main part, press enter. Indicate the cylinder, press enter. Yes, you see, managed to create the hole. Okay, save the file. And well, okay, then as the base of this object, I see there is a rectangular prism. The base is a rectangular prismatic feature. Well, it is total width is 130, depth is 25. Okay, to be able to create the base, I'm going to draw a sketch at the bottom side of the existing one, and then apply the extrusion process. Well, it has been forgotten, the thickness of the base, the height of the base is 5 millimeters. I know this. Okay. The width of the rectangle is 130, and the other size of the rectangle is 25. Okay, and relative to this corner, well, yeah, explain, dear students. On the bottom side surface, the existing part, well, this is my plan. I'm going to mark this point as the origin, and then have the x-axis extending in this direction, x, and y-axis maybe in this sense, and then related to this origin, omitting the rounds along the edges, the location dimension for this point minus 15, and ordinate is 0. Yes. Okay. Do it. So start the coordinate frame displacement process while the surface is being highlighted. Okay, indicate this midpoint, indicate this midpoint, and indicate this corner point. Yes, I am sure XY plane is now coinciding with the bottom side surface of this one, and the origin is the midpoint of this edge. So relative to this origin, create the rectangle. Okay, start the rectangle creation process. Now AutoCAD asking the coordinates of the corner. Abscissa value is minus 15. Ordinate value is 25 divided by 2. This 25 divided by 2 is, clicked on comma key, minus, or say that positive, okay, plus 12.5. Okay, and then move the cursor in the diagonal direction. The width is 130. Clicked on tab key. Height is 25. Press enter. Yes. Managed to create such a rectangle and then apply the extrusion process. Indicate this region. Press enter, and then in the down direction apply the extrusion process. The extrusion length is 5. Okay, and then unify this with the rest. Unification process. Indicate this part, press enter. And then, at both of the sides, I see we have the drills. From the top view, see that the diameter of the drill is 6, and it is the same for the other. This annotation says that not only for the indicated one, but also the identical one. There are two identical features. These are holes, simple holes. Diameter is the same, 6 millimeters. That is the meaning of this annotation. Yes, this annotation says that not only for this drill, but also that drill, the diameter is the same. What? How much? It is 6 millimeters. Okay. The coordinates of the drill, center of the drill, one coordinate related to this boundary is 12.5, the other coordinate is 8. Okay, 8 millimeters. I'm going to move the coordinate frame to here. Well, coincide XY plane with the surface. Okay, check it for midpoints. Yes, there's an enabling. Yes, then while this surface is being highlighted and the midpoint of this edge is also in highlighting, I indicated the midpoint of this edge as the origin and the midpoint of this intersection as the second point along the x-axis, and well, indicate this corner to fix the positive sense of the y-axis. Now xy plane is coinciding and origin is at the midpoint of this intersection. So well, related to this origin, the coordinate of the drill is 8 millimeters. Okay, start the circle creation process, and then abscissa value is 8. Clicked on comma key, ordinate value is 0. These are the coordinates of the center point of the drill. Press enter. And then yes, the diameter of the drill is 6, so the diameter of the circle is 6. Press enter. Okay. And then create the hole. How? Apply extrusion process. Indicate this sketch. Press enter and then create a cylinder in an arbitrary length. This is to cut the material, subtraction process. Indicate the main part, press enter. Indicate the cylinder, press enter. Yes. Do the same thing at the other side. Displacement process. Well, while the surface is being highlighted, indicate this midpoint as the origin, indicate this midpoint as the another point along the x-axis. Okay, do it again. Indicate this midpoint, indicate this midpoint, and indicate this corner point. And then start the circle creation process. Well, the abscissa value is 8. Clicked on comma key, ordinate is 0. Press enter. Diameter is 6. And after creating the circle, apply the extrusion process. Indicate the circle, press enter, and then, well, create such a cylinder in an arbitrary length. The rest is subtraction. Indicate the main part, press enter. Indicate the cylinder, press enter. Okay. Shoot the coordinate frame to word location. And then now I'm going to create the rounds and fillets. Well, these two fillets, for these two fillets, rounding radius is 10. For this fillets it is 5. For the rounds, you see this annotation says that not only for the indicated edge but the other edges are rounded, and rounding radius is 5 millimeters. Okay, then create the fillets and rounds. Along the solid ribbon, find filleting facility, start the process. Click on down direction key and select radius option, and into the box write 10. Press enter and then indicate this edge. And then press enter. Okay, restart the process. I'm sure the radius is the same, 10. Yes, AutoCAD remembers that. the radius is 10. Press enter and then indicate this age and twice clicked on enter key. Yes. Similarly, let's create the other fillets. Start the process, change the rounding radius, filleting radius. It is 5, press enter and then indicate this age. Enter, enter. Okay. Restart the process, indicate this age, enter, enter. Okay. And then round this age, rounding radius, yes, it is 5. For being sure it is 5, yes, it is 5. And then, well, indicate the age. At present these are sharp. Indicate this, indicate this, indicate this, and indicate that, and press enter, enter. Yes, I think well, created all the features. Well, I use this screenshot for my convenience, but since I finished the work, no need to keep it in AutoCAD environment. Select it with a click and push delete button. And then yes, it is the model of the object converted to a solid model. How? Inputting the material. Okay, clicked on visualize tab and then, well, sorry, which visualize, yes, materials browser. It is made of let's say stainless steel. Brass, aluminum. Where is the option? Metal, steel, stainless. Steel galvanized, steel carbon steel, low carbon steel. Okay, select it with a click, move the mouse, drag the mouse toward the model and then release the button. Yes. Close this dialog box and then change the visualization style to shaded with age. Well, it is not in the color of steel. It is still is, you know, its color is gray. It is blue. Why? It is still in the color of the layer, object layer. For the object layer, the selected color, you know, is blue, dark blue. But you know the trick. In Visual Styles panel, drop this list. First select Warm Cool Face Style, and then Realistic Face Style. Then yes, now see the model in the color of steel. It is the solid model of the object. Save the file one more time. Okay, dear students, completed this classwork, and it is to answer the question, the same question, how the solid model of an object is created in AutoCAD. In this example, one more time, studying on this example, you saw the answer of the question one more time. Okay, dear students, Yes, completed the classwork. I'm ending this video record. Bye bye.